Okay class, welcome back. Now that we know the mole ratio and mole-to-mole relationships, we can take it a step farther and talk about mass-mass stoichiometry problems. My goal for today is that we can solve mass-mass stoichiometry problems. So let's dive into this. So I like to think of stoichiometry problems as two buildings next to each other. Each building has three floors named atoms, moles, and mass. On the second floor of each of these buildings, they are connected through a bridge conveniently called the mole ratio. If I am in the mass floor of one building or the third floor of one building and I have to go to the mass floor of another building, I'm going to have to do the following. Go from the mass floor to the mole floor, and then from the mole floor, I'm going to have to cross the mole ratio bridge to get into the mole floor of the second building. Then I'm going to have to go up to the mass floor from my moles to my mass floor on the second building. If you haven't guessed it by now, this is a parallel to how to solve mass-mass problems. In our past videos, we have seen that in order to convert compounds from mass to moles, we're going to have to multiply them by a relationship of 1 mole over the formula mass. Keeping with this illustration, this is how we get from the mass floor on the first building down to the mole floor of the first building. Once we are on the mole floor, all we need to do is to use our mole relationship from the balanced equation in order to cross this mole bridge to get to the moles of the second building. Finally, in order to get from moles on the second building to the mass of the second building, all we're going to have to do is multiply the formula mass of the compound over 1 mole of that compound. Now that we've visualized this pathway, we're going to need to solve some mass-mass problems. Let's try this out. Let's say we are trying to figure out how many grams of ammonia is produced from 56 grams of nitrogen in the following equation. N2 plus 3H2 yields 2NH3. If we are going to solve this, let's first name our two buildings. The building on the left is going to be what we know, while the building on the right is what we're going to be looking for. This means the building on the left is going to be N2, while the building on our right is going to be our ammonia, or NH3. We're given 56 grams of N2, so let's start by writing that down in our nitrogen building. We're wanting to find the grams of ammonia, so let's put a question mark in the mass portion of the ammonia building. Now we have a starting and ending point. If we are going to follow our building illustration, in order to go from grams to moles, we're going to have to multiply our 56 grams by 1 mole over nitrogen's formula mass, which is 28, because nitrogen's diatomic. Now that we have the moles of nitrogen, we can use the mole ratio to get to moles of ammonia. To do this, we just multiply the relationship of 2 moles of ammonia over 1 mole of nitrogen. We get those from the coefficients in the balanced equation. By doing this, we've crossed the bridge between our buildings, and now we are in the ammonia building on the moles level. We're wanting to get grams of ammonia, so now we're going to have to multiply the formula mass of ammonia over 1 mole of ammonia by how many moles of ammonia we have. In other words, we're going to multiply our moles by 17 grams of NH3 over 1 mole of NH3. Once we do this, we get 68 grams of ammonia. Now that we got all this information down, we can mathematically solve it for each step like we've done here, or we can create a string of the relationships we used in this problem like what is shown below on the screen. All we have to do is multiply all of our tops and all of our bottoms and then divide our top by our bottoms, and we still get the same answer of 68 grams. So you can either work it one step at a time or solve it all at once. It's up to you. Here's another practice problem. If I have 45 grams of zinc 2 chloride reacting with aluminum, how many grams of aluminum chloride will be produced? So from this question, we can see that we have a compound of zinc 2 chloride reacting with the individual element of aluminum. This means it is a single replacement reaction. If I'm writing a base formula for this, I would have to write ZnCl2 plus Al yields AlCl3 plus zinc, or zinc chloride plus aluminum yields aluminum chloride plus zinc. Just looking at this equation, we can see it's not balanced, so let's balance it. Now this balanced equation should read 3 ZnCl2 plus 3 aluminum yields 2 AlCl3 plus 3 zinc. Now that we have this balanced equation, we can officially start solving our mass-mass problem. If we can do our building illustration, we can put zinc 2 chloride on the left building and our aluminum chloride on the right building. In this problem, I'm going to solve this step by step and shorthanded at the same time. We are given 45 grams of zinc 2 chloride, so we're going to put that in our mass floor, or just 45 grams of zinc 2 chloride over 1 for our shorthand way. In order to convert this to moles, I'm going to have to multiply it by 1 mole of zinc over the formula mass of zinc 2 chloride, which is 136 grams. That gives me 0.33 moles of zinc 2 chloride. Now we can use our mole ratio to convert our 0.33 moles of zinc 2 chloride into moles of aluminum chloride. This means I'm multiplying my 0.33 moles of zinc 2 chloride by 2 moles of aluminum chloride over 3 moles of zinc 2 chloride, in other words, the coefficients. This gives us 0.22 moles of aluminum chloride. Finally, our last step is to convert our moles of aluminum chloride to grams of aluminum chloride by using the relationship of 133 grams of aluminum chloride over 1 mole of aluminum chloride. This gives me 29 grams of aluminum chloride formed from our original 45 grams of zinc 2 chloride. You can see with our shorthand way, if we multiply our tops and bottoms and divide them out, we still get 29 grams of aluminum chloride. Okay, one last practice problem. Let's say we're trying to find out the amount of sodium it would take to synthesize 42 grams of sodium oxides. First, we're going to write our equation. Since it is a synthesis equation of sodium oxide, it is Na plus O2 yields Na2O. Once we balance this out, we get 4Na plus O2 yields 2Na2O. Now that we have a balanced equation, we can label our buildings. The left one being sodium oxide, while the right one being the single element of sodium. We have 42 grams of sodium oxide, so this is going to go into the mass portion of the sodium oxide building. Now we need to convert to moles by multiplying these 42 grams of sodium oxide by 1 mole of sodium oxide over 62 grams of sodium oxide, or its formula mass. Now we use the mole ratio to get moles of sodium. In other words, we're going to multiply it by the relationship of 4 moles of sodium over 2 moles of sodium oxide. This gets us our moles of sodium, which we then multiply by 23 grams of sodium over 1 mole of sodium. Once we do this, we get about 31.16 grams of sodium needed to produce 42 grams of sodium oxide. I feel that's enough problems to work for this video. The big thing with these kind of problems, these mass problems, and any of these stoichiometry problems is that you need to take it one step at a time. Don't get overwhelmed by it, because these are going to take a lot of practice. And if you try to view it all as a whole entire thing, you're going to get overwhelmed. So if you need to, for now, start up with the building illustration. Eventually, when you get good with it, you can start the shorthand way. But the key is take it one step at a time, and get one conversion done at a time. I hope this video helped you out, and keep up the good work in the classroom. See you next time.